Hello everyone, it's June the 12th. Alright, it's kind of late and we're gonna actually do the challenge from yesterday. So let's go right into it, finish it, and call it a day. Try to do it as fast as we can. Maximum erasure value. You're given an array of positive integers, okay? I want to erase a subarray containing unique elements. The score you get by erasing the array is equal to the sum of its elements. Return the maximum score you can get by erasing exactly one subarray. A subarray is a continuous. So basically, we want to find the maximum sum of a subarray which contains unique values. So in this case, I'm pretty sure it's this one, right? 2, 4, 5, 6. And this one is 8. Optimal is this. Although we can get this 10 to the 5th. So we want to find the ultimate, not the ultimate, the maximum score you can get by erasing exactly one array. So this one, what I smell is pretty much sliding window. How about that? So 4, 2, 4, 5, 6, right? So we can say, okay, we have 4. Now I have 4, 2, right? And then put 4 again, so we definitely cannot. So we move here, so it's 4, 2. And then it's 5, so we can include. And it's 6, we can include. And that's it. So basically, we just grow the window every time if a new value can come in that will still make it unique. We just include until we cannot include it anymore. Then we just kick. We keep kicking until it becomes unique again. Because basically this one is just saying if we have a subarray ending, right, ending at any value. So we'll have a longest, right, ending at a value. If we find that, then we go to the new one. So we just want to see if the new one is still unique, we just add it. If the new one is not unique, right? If the new one is not unique, then we want to find the longest and unique that can contain. So we have to eliminate until this. So that's actually, now that I'm talking about it, it seems pretty clear that a sliding window is just one form, is one way of doing dynamic programming. So we're gonna do sliding window. No issue, okay? Sliding window, and what we're gonna try is using a set, okay? We can call it DP, we can call it set, just fine. And we just say for n in nums, right? And we also have a res and current, both 0. All right, so for n in nums, we say if n not in dp, then dp dot add num and current plus equal to n. Else, we can actually say while. It's not going to be a set, right? It's not going to be a set. So we have to go one by one. Madre mia. What if you put, it's not a set, it's a dictionary, and then we put their indices in it, right? So you find the index. So everybody before that needs to be removed. Then if that's the case, why don't we build, right? And then we will know this. and then we keep going. We just keep adding to it. And once we find, yeah, so every time we go one, we just keep adding. If it's unique, we just keep adding to the previous value, right? And if not, yeah, change idea. What we're gonna do is we're gonna have a pre-sum, okay? A prefix sum. We can start with 0. And then we have this and this. So for n enums, we also need indices. Okay, that's gonna be dictionary. Okay, so we don't need this. Right. And we need I and enumerate numbers. Actually, I just realized that it would be better just to go this way. Okay. Now, here's what we do. So what we're gonna do is we'll build up, right? We'll build up. We say I think it's easier to do this way, right? So we say pre-sum dot append. We always append pre-sum minus 1 plus n. So we build the pre-sum up. And then what? And then what we're gonna say is to find, say if n is not in indices. Okay, so if it's not in indices, oh, we don't need that. We don't need that. What we need is just if it's not in, we return, let's say, 0, right? And then we just minus 0. Think about it. Think about it. If it's in there, then it must be the, well, that's the same thing. Right? That's the same thing. Hold on. Let me think again. That is the same thing. So what we are dealing with is I have the current sum. So current sum is the maximum length starting from the one in front of me, right? And then the current sum. Oh, the current sum. I probably shouldn't say the current sum. I just need the extend, like how far back it extends. And if the current one does not extend beyond, hold on. We do need res, and then this just previous extend, right? That's what I want to know. Previous extend. And then for each one, I check, right? I check the previous extension, like the last time I appear. If the last time I appear is bigger, like more to the left than the previous extension, then that means I can add myself to it. If it's within, then it's going to be this. So in this case, what we need to check, right, is if indices, right, get n, and if not, it's minus 1. If that is smaller than pre-extension index, let's make it more explicit, right? Pre-extension index. If that's the case, oh, but in this one, we probably should start from 1. Enumerate this. I think I should start from 1. So the pre-index, right? We'll have a pre-index. And if it's smaller, that means it's fine. We don't change the pre-index, right? The pre-index stay the same, right? The pre-index stay the same. However, if this one is larger or equal to, right? So the last occurrence is larger or equal to the pre-index. That means I need to change the pre-index. So I say pre-extension index needs to equal to indices dot get n minus 1, this one plus 1. Right, that would be the new pre-index. Okay, so after we do that, we can say res equals maximum res and pre-sum I, the current one, minus pre-sum pre-extension index, right? Pre-extension index. Pre-extension index shall be the entire thing, like how much I can extend. I just realized it should be pre-extension index minus 1. Right? It shouldn't be minus 1. Then we shall start at 1. Right? We should start pre-extension. This is like the most left I can extend. Given something, the most left I can extend. So in this case, this one should be 1. And this should be minus 1. Right? If that's the case, first one coming in, I will always extend pre-sum, and it's not going to be larger than pre-extension. So now we're going to do the current I minus this will be 0. So we get a current value, right? And then we just keep going. Everything is positive. Yeah, we just res equals to this, then indices n shall equal to I. Keep going, and then we're going to return res. All right, let's try this. What do we have? We have this, 17, and this is 8. Okay, this is nums. This is a maximum nums. Let's run this. Okay, so far so good. You want to try some edge case. So this is actually exactly the same as the one that we had in the past. Two kind of edge-ish cases. Yeah, I think this one should be right. Let's see. Last time I do it about a year ago, a little bit over a year ago. Okay, so everything looks fine. Let's check. Sanity check. Pretty sure this is the solution, right? Unless we have a better one back then. 1695. The technique, right, is the same as the problem yesterday and as the problems in the previous days. Right, we use dict to record the indices of the last occurrences of each number. Each time a value end, and we use a prefix sum to quickly compute the sum of any subarray. Each time a new number is encountered, we check whether its last occurrence, right? As its last occurrence happens within or outside the longest unique subarray ending in the number to the left, right? To the left of the current number. If it is outside, we can add the current number to the longest unique subarray of the number to the left. Otherwise, we have to recompute the range, which cannot include the last occurrence of the current number. So overall, it's O n in time and O n in space, and then we hit 1872 milliseconds. I just want to confirm. This is 62 test cases, 1872. 62 test cases is faster. I use CumSum, I use this, -1. Yeah, can use -1. And this pre-index, yes. Yeah. Minus. Yeah, the same idea. Okay, that's about it. And I'm gonna call it because it's getting late. I will not do this. Probably do this. Wait, this one looks familiar. Anyway, so that will be it for today. I'll see you guys later today because it's already like 12:30 right now. So I'll see you guys later today. Adios.